Lesson 89, More Value Problems. So we are learning how to read a word problem and turn it into either a substitution or an elimination series of equations so that we can compare the two equations to one another and find our respective answers. So in example 89.1, we are told that airline fares for flights from Tifton to Adele are $30 for first class, and they are $25 for tourist class. Those would be the cheap seats. And if a flight had 52 passengers who paid a total of $1,360, how many first class passengers were there? So that's our question. First class, how many? So the number of first class, I guess would be the better way to write that. All right, so from the information that we have, we can create a couple of statements. First of all, we know that the number of first class tickets plus the number of tourist class tickets equaled a total of 52 tickets. So we can write that statement. The number of first class tickets plus the number of tourist class tickets equaled 52 tickets because we had 52 passengers. So that is a true statement. Now we can create another true statement, and that is based on the value of those tickets. We know that 30 times the number of first class tickets plus 25, because that's the value of the ticket, times the number of tourist class tickets equaled $1,360. So that's another statement. So that's how we're making our elimination and substitution equations from this information given. And in order to do that, we have to have a total for the number and a total for the value. And we also have to know the value of each one. So we can do a comparative analysis using elimination or substitution. In this case, we're going to use elimination. So in order to do that, we're going to have to multiply this entire equation by a number so that we can eliminate one of the variables. And we're going to use negative 30 to do so. So let's say negative 30 times the number here is negative 30 times the number of first class, and negative 30 times 1 here. So it's going to be minus 30 times the number of tourist class, and negative 30 times 52 is going to be a negative 1560. Now we can eliminate. These two cancel. We're left with a negative 5 times the number of tourist class equals a negative 200. And if we divide both sides by negative 5, the number of tourist class tickets was 40. Now we can easily sub this in to get our answer for the number of first class. And if we subtract 40 from both sides, we know that the number of first class tickets was 12. Now, if we wanted to check our answer, we could easily take this problem here. The number of first class tickets, which was 12, would say 30 times 12 plus 25 times the number of tourist class tickets, which was 40. And that should equal 1360. And in this case, we have 360 plus 1,000 equals 1,360. So that checks. So we got the right answers. Okay, that's how you make those statements. That's how you write those problems. You need the value of the items, you need the total number of the items, and you need the total value of all the items added together. And then you can write these statements. Let's try one more. 89.2. So Watakasha's dress shop sold less expensive dresses for $20 each and more expensive ones for $45 each. So let's write that now. We have 25 for the less expensive dresses, and I'm sorry, not 25. It's 20 for the less expensive dresses, and the more expensive dresses were 45 each, and those were the more. Okay. The shop took in $13.75 and sold 20 more of the less expensive dresses than the more expensive dresses. So the less expensive dresses, let's say the number of less expensive dresses was the number of more expensive dresses plus 20. So that's our total number. So we can create a statement. Here's one statement already created for us. We can create a second statement that says $20 times the number of less expensive dresses plus $45 times the number of more expensive dresses equaled 1,375 that day. All right, so that's our other statement. Since we have already solved here for NL, we know what NL equals. It equals NM plus 20. We can substitute this statement here, or this binomial, for the variable NL, since that's what it equals to. So we can say 20 times NM plus 20 plus 45 NM equals 1375. Now we can go ahead and distribute, and that's going to be 20 times the number of more expensive dresses plus 400 plus 45 times the number of more expensive dresses equals 1375. All right, we're going to subtract 400 from both sides. And then we're going to combine these together. And that's going to be 65 of the more expensive dresses equals $975. So if we divided both sides by 65, we would find out that the number of more expensive dresses that were sold that day was 15. So to find the number of less expensive dresses, we are just going to sub 15 in for this problem here. So the number of less expensive dresses sold that day was 15 plus 20. So the number of less expensive dresses sold was 35. All right, so if we wanted to check that, we could sub in. I'm going to change it to blue to show our check. We could sub in the values, or the numbers, since we have the values. So the number of less expensive dresses was 35 plus the number of, the value of the more expensive dresses was 45 times the number of the more expensive, which was 15, should equal 1375. So let us see if that is the case. So 20 times 35 is going to be 700 plus 45 times 15, that is going to be, oh goodness, I'm doing this in my head. So 10 times 45 is 450. Half of that is 225. 75, 675. All right, so 675. Does that equal 1375? I believe it does, because 600 and 700 is 1300, and then we have 75. So that checks. So these answers are both correct. So you can see all that you need is the value and then the totals, whatever form those totals might be. And that's all we have for lesson 89. It's a very short lesson today. Just a little bit more on how to set those up. And if you have any questions, please write them down and bring them to class or submit them to me. And I will see you in lesson 90.